Hey guys, today we're going to be talking about plotting histograms in Python. And specifically, we're going to be plotting probability distributions overlaid with normal distributions. So what I'm going to be doing is focusing on the kernel density function, which is an estimate for the probability density function, and it's a way of smoothing some of the data. But if you don't know what that means or you haven't dived in statistics, don't worry about it too much. What I do want you to take away from this video is how to plot two normal distributions on the same Matlplotlib graph in Python. So a lot of this code, like the Pandas, the Numpy, and the Matplot, these modules, this is just for Pandas is for data science, Numpy is for scientific computing, and Matplot is just for plotting and showing graphs. And then further down here, you can see I've written some code that would plot the KDE or kernel density estimate. And if you want to go over it, you should familiarize yourself with it. But what I'm going to be focusing on is kind of an explanation of how you'd write code in Python to plot two different graphs on the same matplotlib. So we'll begin. So we need to create the means, and I'm just arbitrarily picking some mean values, which is what the graph is going to be centered around for each of these plots. Then we need to get some standard deviations. And again, I'm just arbitrarily choosing some values. And now I'm going to create a variable that's going to hold our called distro, which is for the distribution. And the PD is coming from the Pandas, which is scientific data. I'm creating a data frame. You guys can research this some more if not everything is already crystal clear. So I'm using the random module to choose values, and I'm basing that off a normal distribution. And there's some attributes in here that we have to solve for. So the location, obviously, of the graph is going to be around the means. We're going to scale each bin, which is each width column. So each column is its width is going to be based off the standard deviations. And now we're going to make a size of the total sample that we're getting. So I'm just arbitrarily going to choose 2,000 samples for both of them. So, and then we need to deal with the columns. So I'll call the columns, what should I call them? I'll call them not Y and Z. I'll call them column 1 and column 2. How about that? That should work out. So now what we need to do is I want to create a table based on, I'll call it distribution table, and we based off the random variables that are being processed by the KD or by the normal distribution based on the arbitrary values I gave for the mean and the standard deviation. So ag, it's going to aggregate all these, and I'm going to give it some standard values that you normally see in statistics, like the min, max of all this. Also, we want to spit out the mean and standard deviation for each of these different functions. And here, the round, I'm just using a little bit of formatting. We want to do it to 3 decimal places. It should be sufficient. Oops. Yeah, and we will print out the distribution table. Okay, it's saying I have a bit of an error. Distribution, right. Where is my error? Decimals. I'll find the error. Just give me a second, guys. It could be further up here. And I'm not really seeing my error, which is strange. Maybe it's in here. That may be it. Or not. So I'm going to try and get it. Invalid syntax. So let's see. Let's see what this does. Saying in line 11. Oh, I put two D's here. Okay. So let's see if this works. Okay, so it worked. So basically, as you can see down here in the table, it's for your first column, your second column, for the two we created, you can see your min values, your max values of these random distributions, the means. See, for the first one, it's 15.199, and that's very close to what I put for the actual mean, which is 15, and then 34.96, which is also pretty close, and same for the standard deviation, 5.99 and 12.016. And then on the histogram, so for number one, it's in green. You can see that if you go down, it looks like it could be centered around 15 if you go up and down, and same with the center of the density here, it could be around 35. So that was just a quick video on how to create a histogram with two different plots on it on the same axes. I hope you guys enjoyed it, and again, all the code will be linked in the description on GitHub, so don't worry about keeping up with the coding while I speak. Just download it and study it for yourself. So bye for now.